This is chapter 10, section 1, number 65, and they want the Lagrange error bound. So, couple things to note. The centers is 0 because we don't have x minus anything. So we know a is 0. Now when we pick our c for the Lagrange error bound, the c must be between the point being approximated and our center. Well, if our center is 0, if we happen to use the point 2, c would have to be between 0 and 0.2. But we don't know what value we're using in this range. So the other extreme would be from negative 0.2 to 0. So center to the x value on the left extreme, center to the x value on the right extreme. And since it could be any of these, if you combine those, the conclusion is c must be between negative 0.2, that is so bad. C must be between negative 0.2 and 0.2. So that's our C range. Now, this f of x is ln of 1 plus x. Since this is a second order, we use the third next term, which is a third order term, to find our Lagrange error bound. So we need the third derivative. So the first derivative is 1 over 1 plus x, which I'll rewrite to be this. I take the second derivative, we use the chain rule because it's box to the negative 1 power. So that's negative 1 box to the negative 2 power times derivative box, which is 1, so it doesn't change anything. And then the third derivative is going to be 2, 1 plus box to negative 3 times derivative box, which is 1. So that's just 2 over 1 plus x cubed. So what is our Lagrange error bound? So it's going to be the third at some x, the remainder, or we can call it the error, or we can say it's the actual value f of x minus our Taylor polynomial, which now we use the Lagrange error. We want the maximum value, a number bigger than or equal to, for c between negative 0.2 to 0.2 of the third derivative, which is 2 over 1 plus c cubed. And the largest x is going to be 0.2. And we want to cube that over 3 factorial. Okay, now we have to use our thinking caps. When is a fraction the biggest it could be? You should say when the denominator is the smallest it could be, right? So when is it going to be the smallest? I claim at negative 0.2. because that makes it smaller because you're subtracting. So I claim this is less than or equal to 2 over 1 minus 0.2 cubed times 0.2 cubed over 3 factorial. Now that can be simplified. So you probably don't need to, but I'm going to say that's equal to. The bottom is 0.8, which is 4/5 cubed, 0.2 cubed over 3 factorial, which is 2 times 4 cubed times 0.2 cubed. And I probably could have changed that 0.2 to 1/5. Let me do that. Let me do that for you. 1/5 cubed, which is on top, we have a 2. Now this is crazy. We're going to have a 5 cubed. I'll explain that. And on the bottom, we're going to have a 4 cubed a 5 cubed, and a 3 factorial. How did all that happen? This gets flipped. So the 5's on top and the 4's on bottom. So 5 cubed on top, 4 cubed on the bottom. That 5 cubed is on the bottom, and that's on the bottom. So, oh, nice. Nice. How nice. That is pretty. And then, what's 4 cubed? Is that 64? I believe it's 64. And that becomes 32. And that's 6. Hey Siri, what's 6 times 32?
6 times 32 is 192.
Is that the answer? I think it is. Let me stop this video.